Hello everyone, today I will discuss assignment 7 for the course Introduction to Soft Computing. In this assignment, question number 3, 4, 7 are a little bit tricky, but question number 7 is most tricky question, so just we have to take care. Question number 1, which MOGA technique? MOGA technique means multi-objective genetic algorithm technique use crowding distance to select a better solution. So for better solution and for crowding distance, the correct answer is NSGA2. NSGA2, that is non-dominating sorting genetic algorithm. And this algorithm is updated version of NSGA, right? So correct option is B. And this is the validation that NSGA2, in this NSG2, this is accomplished by calculating crowding distance of solution in the last acceptable front. Therefore, uh, this will be the correct answer 100%. Question number 2. In NSGA, dummy fitness value are assigned to each individual solution belong to a particular non-dominating front. The dummy fitness value are usually kept. So first of thing, dummy fitness value kept very high or very large. So first two options are incorrect. So very large and population to the total number of non-dominated front. This option is also wrong. Actually, very large dummy fitness value will be very large and proportional to population size. So option D is the correct one. So question number second, validation. The dummy fitness value is very large number and typically is proportional to the number of population. Okay, so therefore option D is correct one. Question number 3. Consider two objective optimization problem. It may be possible there are 3 objective, 4 objective, but in this question there are 2 objective function f1 and f2, and f2 we have to maximize and for f1 we have to minimize. So this is f2, that is minimize, and this is f1, that is maximize. So which of the following statement is correct about the dominance relationship and non-dominated front of the above solution? So the correct answer is option D, because for this question you have to read and validate the videos very carefully. After that is just you can apply the fundamental concept, and therefore option D will be the correct one. But in the assignment, but in the video, this question is directly being asked. So this is the validation, and one front is this one, another front is this one, and this is the third front. So the ordering of the solution in terms of their non-domination, that is 3, 5, 1, 4 and 2. Therefore option D was the correct ones. Question number 4. As per the crowding comparison operator, which of the following statement is wrong? We have to find out the wrong statement. A solution xi is selected over another solution xj if dominance rank of this statement is correct. A solution this is selected with another xj if rank is equal to equal and crowding distance is less than crowding distance of this one. So this option is incorrect. Option 3 is correct, and none of this will be incorrect. Therefore incorrect statement for question number 4 is option B. Okay, why? uh, because if the dominance rank is less than and greater than, okay, but in this one is the given statement which is wrong. So this is the standard definition for crowding comparison operator. So statement 1 and both these two statements are same one statement. So you from this solution you can validate that which one is correct. Which of the following logic can't be modeled with a single neuron? Which of the following logic? When you will see the video that there are in the video they are demonstrate that and logic gate and JOR logic gate with the help of single neuron, with the help of single neuron and logic is possible, AND logic is possible, but with the help of single neuron, JOR या XOR logic is not possible, right? Therefore, option B is correct one, right? And this is the validation. Uh, JOR problem is known because in this y is equal to 1 and y is equal to 1, right? So this, uh, this is a non-linear separable problem, and when we are going to divide it, it is impossible that we are going to make with help of single neuron, but with help of multi neural network this can be possible. So in case of JOR problem, such a line is not possible, right? So with help of single neuron, XOR gate, yeah, XOR logic is not possible. Question number 6. In a MOOP, there are m different objective. Okay, there are m different objective like F1, F2, and FM, and n is the initial population size. So with help of NSGA2 method is utilized to solve the MOOP. The time complexity of crowded tournament selection procedure in this case will be equal to, this will be equal to option D. Because when we are going to use this type of algorithm for multi-objective optimization problem, time complexity is very crucial parameter and it must be minimum. Otherwise, algorithm will not be so effective. So question number 6 validation is this one. It does not require an explicit sharing concept rather than use a crowding tournament selection with time complexity, this one. O mn log n, right? So overall time complexity of NSJ2 is OMN square. OMN square, right? So question number 6, 7. So this one is the tricky one. The error calculation which is followed in back propagation algorithm is the steepest descent method. This statement is true. Simulated annealing approach is followed in unsupervised learning. When I search for simulated annealing approach, this approach can be used in supervised learning and unsupervised learning both, but generally it is used for the unsupervised learning. So I can say this statement is also true. A problem whose output is linearly separable can also be solved with help of this. Definitely it is true. With if a simple problem that can be solved with single neural uh, single layer feed forward neural network, that can be also executed with the help of multi-layer feed forward neural network. The output of the perceptron with hard limit transfer function. Hard limit transfer means like step function, this, like, and sigmoidal function like this, when like this. So is defined with any, is more accurate than it is defined. Actually it can give you the accurate result, but sometimes it depend upon the data type and type of problem. So all the statements are true. Therefore according to me option D will be the correct one, but you can search yourself for valid answer, and if you can give me the best update on YouTube comment, so just let me know so that we can update. But according to me and what I investigated, according to that option D is the correct one. And if you are able to solve it more accurately, please let me know with the help of comment. So this is the validation for question number 7. Question number 8. Which of the following MOEA algorithm is based on concept of elitism? So NSGA2 is the based upon elitism, that is non-dominated sorting genetic algorithm 2, and NSGA was not based on elitism. Question number 8 validation. This is the question being asked in previous year. Same question, elitism. So NSGA2 is the this one. And when we will going to this elitist multi-objective genetic algorithm, that is NSGA2. So with the help of these two proofs we can validate our answer. Question number 9, very simple, straightforward. Which of the following function is known as 10 sigmoid transfer function? 10 sigmoid. Therefore, option C will be the correct answer, and it is a based upon formula. So just cram the formula, and you will solve the question with easy way. So this is the validation. So there are two type of function: log sigmoid function and 10 sigmoid function. So in 10 sigmoid function, this is the formula. So with the help of this, we can validate our answer. Question number 10. We are given a single neuron, and x1 and x2 are the two inputs, w1 and w2 are the two weights, and bias is also given, that is b. So we have to validate our AND logic, and for AND logic we already know when output will be 1 when both inputs will be 1. Okay, and in rest of the combination output will be equal to output will be equal to 0 1 1 0 and 1 1 and 1 1, and first condition is 0 0. So in AND logic, output for first three condition will be equal to 0, but for last condition it will be equal to 1. Okay, so just there are four condition will be given. These are the x1, x1, and another is the x2. So these are the two input x1, x2, and we are given w1, w2, and bias this. So when we are going to solve it, and when this will be hold. Okay, so in first three statements, this uh, all these three combination will be hold, but when we will execute this, that is option D, then option and this uh, setup, that is w1.5, w2.5, and b is equal to minus weight, so this will not be valid. So and we have to find out the uh, which of the four to input this, the summer block this, which of the following weight and bias value set is not valid. So not valid, option D, and this is the validation for this. Option A correct one, option B correct one, option C correct one, but in this case all the outputs are 0, therefore this statement is not valid. So correct answer is D. So thank you so much. I hope accuracy will be 100%, but in every assignment one question is found to be wrong, and I don't know, as per my solution and as per my investigation it should be, but for assignment in the last assignment I put the feedback and helping to give the correct solution so that I can validate, so that in the final assessment or final exam I can put the right answer. Thank you so much. Next assignment will be updated very soon. Thank you so much.